2 billion light-years across, stretching in every conceivable direction from where you currently exist, the architecture of the cosmos is fundamentally broken. If you were to map the distribution of matter across the observable universe, every galaxy, every cloud of primordial gas, every cluster bound by dark matter, you would expect a certain density, a uniform scaffolding of mass dictated by the earliest moments of creation. But the instruments measuring the microwave radiation left over from the birth of time are registering a physical anomaly that defies the foundational laws of modern cosmology. At -270 degrees Celsius, in the silent vacuum of deep space, our most advanced orbital observatories capture photons that have been traveling for billions of years. These photons strike beryllium mirrors, transferring their infinitesimal energy into digital arrays. It is a purely mechanical process. There is no room for interpretation or human bias in the raw data. When we look out into the deep field, beyond the local group of galaxies, the light arriving at our observatories carries a spectral shift. This redshift is the physical stretching of light waves as the universe expands. It is a measurable, tangible metric. We calculate the velocity of galaxies moving away from us, and from that, we derive the density of the space they occupy. For decades, the numbers aligned with a terrifying but predictable elegance. The universe is expanding, cooling, and dying. But recently, the precision of our instruments reached a threshold where the data could no longer be smoothed over. When observatories scan the immediate 2 billion light-years surrounding the Milky Way, they find that the galaxies at the edges of this perimeter are being violently pulled outward. They are accelerating away from us at a velocity that the standard model of physics simply cannot account for. It is not a subtle margin of error. It is a massive structural deviation in the gravitational mechanics of our local universe. The kinetic energy required to pull thousands of galaxies outward at these anomalous speeds is staggering. Matter attracts matter. Therefore, a severe lack of matter acts as a gravitational vacuum. The dense superclusters lying far beyond our visual horizon are exerting a stronger gravitational pull than anything within our vicinity, dragging the edges of our local space away from us. Imagine standing in the center of a sprawling, ancient forest, assuming the trees stretch uniformly across the entire continent. You measure the wind, the soil, the distance between the trunks, and everything makes sense. But then you realize the trees at the horizon are leaning outward, pulled by a gravitational mass you cannot see, leaving you standing in a hollowed-out clearing you never knew existed. Our galaxy is sitting in the center of a cosmic desert, a vast spherical expanse where the density of matter drops drastically compared to the rest of the universe. The photons hitting our satellite sensors paint a picture of an immense emptiness. A region so devoid of mass that the gravitational pull from the denser regions outside of it is actively tearing the edges of our local neighborhood apart. We are not just floating in the quiet suburbs of a galaxy. We are stranded in a profound structural anomaly, a gravitational crater, a spherical dead zone that spans a volume of space so incomprehensibly large that it takes light itself 2 billion years to cross it. And this lack of matter is not just a geographical curiosity. It is actively warping our measurements of time, expansion, and the ultimate fate of the cosmos. The numbers are fractured. The expansion rate of reality itself changes depending on whether we look inside our local perimeter or beyond it. We have built our entire understanding of physics assuming we occupy a normal, representative patch of space. But the cold, hard data now suggests that we are looking at the universe from the bottom of an abyss, a structural flaw in the cosmic web. To understand the sheer magnitude of this structural flaw, we must first dismantle a comforting illusion that has dominated our understanding of reality for nearly a century. The human mind is biologically wired to seek order. When we look at a chaotic system, our brains violently force a pattern upon it. We assume that if we zoom out far enough, the chaos will smooth itself out into a predictable, uniform canvas. In astrophysics, this psychological coping mechanism was elevated to a fundamental law. It is known as the cosmological principle. It states that, on a large enough scale, the universe is both homogeneous and isotropic. This means that no matter where you are and no matter which direction you look, the universe should look essentially the same. The laws of physics demand balance. Matter should be distributed like particles of gas in a sealed room, spreading evenly, predictably, without massive clumps or inexplicable vacuums. It was a beautiful, elegant assumption. And for a long time, the numbers seemed to validate our arrogance. But science is not driven by assumptions. It is driven by the cold, mechanical capture of photons across the void. The slow dismantling of this illusion did not begin with modern supercomputers or deep space satellites. It began in the freezing darkness of an observatory in Arizona over a century ago. Imagine the physical labor of early cosmology. Heavy glass plates coated in volatile chemical emulsions, exposed to the night sky for hours at a time, capturing the faintest smears of light from distant nebulae. Vesto Slipher, operating the telescope in the freezing cold, passed this starlight through a prism, splitting it into its component colors. What he found embedded in those glass plates was a physical impossibility at the time. The light from nearly every distant nebula was shifted toward the red end of the spectrum. The physics of this phenomenon are entirely unforgiving. When an object emitting light moves away from you, the waves of light are physically stretched over the expanding distance. The peaks of the waves hit your instruments less frequently. The wavelength lengthens, and in the visible spectrum, longer wavelengths appear red. This redshift is not an optical illusion. It is the mechanical signature of cosmic expansion. Slipher realized that these nebulae were not just clouds of gas within our own galaxy. They were entire island universes, galaxies containing billions of stars, and they were fleeing from us at terrifying velocities. Shortly after, Edwin Hubble built upon this terror, combining Slipher's velocities with distance measurements. To measure the distance to a galaxy millions of light years away, you cannot use parallax or simple geometry. You must find a light source whose absolute intrinsic brightness is known to a mathematical certainty, and compare it to how faint it appears from Earth. We call these standard candles. The early standard candles were a specific class of dying stars called Cepheid variables, discovered by Henrietta Swan Leavitt. These massive, unstable stars pulsate, expanding and contracting with a brutal rhythmic violence. Leavitt discovered a flawless mathematical relationship between the time it takes for a Cepheid to complete one pulse and its true luminosity. When you know exactly how much light a star is violently radiating at its source, and you measure the pathetic fraction of those photons that manage to survive the journey and hit your telescope mirror, the inverse square law of light gives you the exact distance. It is not an estimate. It is a precise physical measurement grounded in the unyielding laws of thermodynamics and electromagnetism. Hubble mapped the distances. He mapped the velocities. The conclusion was undeniable. The further away a galaxy is from us, the faster it is accelerating into the dark. The universe was not static, it was expanding. This relationship, the rate at which the universe expands, became the ultimate metric of cosmology, the Hubble constant. To calculate this constant is to calculate the age, the density, and the ultimate fate of reality itself. For decades, it was the holy grail of astrophysics. We built larger mirrors. We launched orbital observatories above the atmospheric distortion of Earth. We abandoned pulsing stars for the thermonuclear detonations of white dwarfs, type Ia supernovae, cosmic explosions so blindingly violent that they outshine entire galaxies. These supernovae operate on a strict mass limit. When a white dwarf cannibalizes enough matter from a companion star to reach precisely 1.4 times the mass of our Sun, its carbon-oxygen core collapses under its own gravity, triggering a runaway nuclear fusion event. Because they explode at the exact same mass threshold every single time, their absolute luminosity is identical. They are the perfect cosmic yardsticks. Using these exploding stars, we mapped the expansion of the local universe with an unprecedented surgical precision. The measurements dictated that space is expanding at a rate of roughly 73 kilometers per second for every megaparsec of distance. The math was solid. The observations were confirmed, repeated, and heavily scrutinized. We believed we had decoded the mechanical heartbeat of the cosmos, but the universe does not care for our local victories. While one faction of astrophysicists was measuring the explosive deaths of stars nearby, Another was looking back to the very genesis of time. The European Space Agency launched the Planck satellite, an instrument designed to map the cosmic microwave background. This is the afterglow of the Big Bang itself. It is the oldest light in existence, released when the universe finally cooled enough to allow the first atoms to form, roughly 380,000 years after creation. Before this moment, the universe was an opaque, screaming plasma of subatomic particles. When it cooled, the plasma cleared, and the first photons traveled freely through space. The Planck satellite captured these photons. It mapped the microscopic temperature fluctuations in this ancient radiation, anomalies no larger than a fraction of a degree. These infinitesimal variations in temperature are the primordial acoustic waves, the gravitational ripples that eventually dictated where galaxies would form and where empty voids would remain. By analyzing the scale of these ripples, astrophysicists can calculate the precise density of matter and dark energy in the early universe. And from that density, they can predict exactly how fast the universe should be expanding today. The calculation from the dawn of time yielded a fundamentally different number, 67.4 kilometers per second per megaparsec. This is not a minor statistical error. This is a catastrophic failure of the standard model. It is known as the Hubble tension, and it is tearing the foundations of modern physics apart. You cannot have a universe that predicts one rate of expansion from its birth and visibly demonstrates a violently faster rate of expansion in its current, local state. Both measurements are flawless. The supernova data is heavily cross-examined. The cosmic microwave background data is the most precise map of reality ever constructed. They are both mathematically perfect, yet they contradict each other entirely. For years, scientists assumed a hidden flaw in our instruments or our algorithms, but as the error margins shrank into oblivion, a darker, much more unsettling truth began to emerge. A truth that requires us to abandon the comforting illusion of the cosmological principle. The math only contradicts itself if we assume the universe is uniform, if we assume the density of space is the same everywhere. If the galaxies in our immediate vicinity are fleeing away from us significantly faster than the cosmic average dictates they should, there is only one physical mechanism capable of causing that acceleration: gravity, or rather, the terrifying absence of it. If you are placed in the center of a dense cluster of matter, gravity holds you in place. It counters the expansion of space. But if you are born in the center of an immense void, a region where the density of galaxies is drastically lower than the cosmic average, the gravitational dynamics invert. The dense superclusters of matter that lie far beyond the borders of this void exert a massive gravitational pull on the galaxies inside it. The edges of the void are actively pulled outward toward the denser regions of the universe. The galaxies within this local region are not just riding the underlying expansion of space. They are being forcefully dragged toward the heavy rims of an unfathomable cosmic crater. This extra gravitational pull artificially inflates the redshift measurements of local galaxies, making it appear as though the entire universe is expanding faster than it actually is. We are measuring the localized collapse of a massive vacuum. The tension between the early universe and the local universe vanishes the moment we accept our isolation. The data heavily suggests that the Milky Way, the Andromeda galaxy, and the entire local group are trapped near the center of a monumental density anomaly. It is named the KBC Void after Keenan, Barger, and Cowie, the astrophysicists who charted its terrifying dimensions. To call it a hole is a vast understatement. It is a spherical expanse roughly 2 billion light-years in diameter. Within this colossal perimeter, the density of matter is 20% lower than the cosmic average. The scale of this emptiness is completely irreconcilable with our models of how the universe formed. According to the quantum fluctuations of the early universe, a void of this magnitude simply should not have had enough time to form. The gravity of dark matter should have smoothed it out, and yet the data insists it is there. We are completely enclosed within it. Our entire history, every star we have ever named, every galaxy we have catalogued with our optical telescopes, exists deep within this impoverished sector of reality. We thought we were observing the grand architecture of the cosmos, but we have only been staring at the walls of our own localized cage. The implications are deeply unsettling. It means that our fundamental perception of physical reality has been distorted by our geographic disadvantage in the cosmos. We are looking at the universe through a distorted lens, a gravitational sinkhole that skews our geometry and our understanding of time itself. We have built laws of physics based on the assumption that our neighborhood is normal, only to discover that we inhabit a desolate ghost town on the outskirts of reality. If the relentless pursuit of absolute, unvarnished truth in the darkest corners of astrophysics is what drives you, then do not walk this path alone. Subscribe and join us as we continue to dismantle the illusions of the cosmos. Because realizing that we are trapped in a 2 billion light-year vacuum is only the first step. The true terror begins when we attempt to map the sheer scale of the boundary and what happens when the physics we trust refuse to map the darkness. To grasp the scale of the anomaly we are trapped inside, you have to completely abandon your earthly perception of distance. When we speak of 2 billion light-years, the human brain simply fails. It renders the number as abstract mathematics. But it is not abstract. It is a physical, terrifyingly real stretch of geography. Imagine a single photon of light. It is born in the nuclear furnace of a star on the extreme outer edge of this void. It bursts outward, traveling at 300,000 kilometers every single second. It crosses the distance from the Earth to the Sun in 8 minutes. It crosses our entire solar system in a matter of hours. It leaves the Milky Way galaxy behind in 100,000 years. And yet to cross the dead space of the KBC Void, this photon must travel at that maximum cosmic speed, relentlessly, in a perfectly straight line for 2,000 million years. During the time it takes that light to cross the void, on our planet, entire oceans boil away and reform. Continents are torn apart by tectonic violence and slammed back together. Single-celled organisms evolve, crawl out of the mud, build civilizations, map the stars, and eventually build the instruments to capture that exact same photon. That is the physical thickness of the emptiness surrounding us. And within this unimaginable volume of space, a massive percentage of the universe is simply missing. To understand how we know this, we have to look at the cold, mechanical reality of how modern astronomy is actually done. We do not look through eyepieces anymore. The mapping of the universe is an industrial process. Consider the Sloan Digital Sky Survey. High in the Sacramento Mountains of New Mexico, sitting at an elevation of nearly 9,000 feet to escape the distortion of the lower atmosphere, is a telescope completely dedicated to mapping the structure of the cosmos. For over 2 decades, it has operated with a brutal, automated efficiency. Every night, astronomers take massive, heavy aluminum plates and physically plug thousands of individual fiber optic cables into microscopic holes drilled with absolute mathematical precision. Each hole corresponds to the exact coordinate of a distant galaxy in the night sky. The telescope locks onto the deep field. The starlight from thousands of different galaxies travels down these cables simultaneously and hits a spectrograph. It splits the faint ancient light into its raw chemical components, measuring the redshift, the speed at which those galaxies are fleeing from us. Night after night, year after year, this machine churns out data, plotting the exact 3-dimensional position of millions of galaxies. When you feed this massive ocean of data into a supercomputer and plot the coordinates in a 3-dimensional model, the true architecture of the universe is revealed. And it is not a random scattering of stars. It looks like biological tissue. It is a cosmic web. Gravity has spent the last 13 billion years pulling matter together into massive glowing filaments. These threads of galaxies stretch for hundreds of millions of light years. Where these filaments intersect, they form nodes. These nodes are the superclusters, the most massive, violent gravitational structures in existence, containing thousands of galaxies bound together in a swirling dance of dark matter and superheated gas. And between these glowing threads are the voids, immense desolate regions of utter blackness where matter has been entirely evacuated, pulled away by the gravity of the filaments. The universe is a sponge, a structure of dense webs and empty pockets. Under normal circumstances, A typical void in the cosmic web is maybe 100 million, perhaps 200 million light-years across. They are common. They are mathematically expected. They are the empty rooms in the grand architecture of reality. But the KBC void, the emptiness we reside in, is nearly 10 times larger than a standard void. It is a structural monster. It defies the physics of how the cosmic web is supposed to form. To build a void of this magnitude, the universe would need significantly more time than 13.8 billion years. The expansion of space and the gravitational pull of dark matter operate at a specific, measurable speed. There has simply not been enough chronological time since the Big Bang for an empty space of this sheer catastrophic volume to have been carved out. And yet, the aluminum plates and fiber optic cables in New Mexico, along with radio telescopes across the globe, confirm its existence with mechanical certainty. When we calculate the mass density inside our local 2 billion light-year perimeter, we find it is 20% lower than the cosmic average outside the void. 20% may sound like a marginal difference, but on a cosmic scale, 20% of a sphere 2 billion light-years wide represents a mass deficit that breaks the mind. We are talking about the missing mass of tens of millions of galaxies, billions upon billions of stars, planetary systems, black holes, and dark matter halos that simply do not exist in our sector of the universe. Imagine looking at a satellite map of the Earth at night. You see the glowing interconnected webs of cities, New York, London, Tokyo, the bright highways connecting dense populations. Now imagine zooming in on a massive section of the globe, an area the size of the entire Pacific Ocean, and finding almost no lights. A sprawling, desolate black zone in the middle of a crowded planet. That is where the Earth, the Sun, and the Milky Way are currently drifting. But our isolation is not peaceful. The physics of this missing mass create a violent gravitational dynamic. Because we are lacking 20% of our local matter, the surrounding universe is overpowering us. The dense, heavily populated filaments of the cosmic web that form the walls of our void are incredibly massive. And gravity is absolute. The heavy walls of the void are pulling on the galaxies trapped inside. We can physically measure this phenomenon. We call it peculiar velocity. While the entire universe is expanding, carrying all galaxies away from each other, galaxies also have their own localized motion, driven by the gravitational pull of their immediate neighbors. When we map the peculiar velocities of the galaxies within the KBC void, we see a unified, terrifying current. They are flowing outward. They are migrating away from the center of the emptiness, accelerating toward the dense borders of the void. Our own galaxy is caught in this massive, invisible current. The Milky Way, along with our neighbor Andromeda, is hurtling through space at roughly 2 million kilometers per hour. We are not just drifting aimlessly, we are being pulled. For a long time, astrophysicists sought the source of this pull. They looked in the direction we are heading, mapping the dense regions of space, and they found a massive concentration of mass called the Great Attractor. It is a region deep within the Centaurus supercluster, tens of thousands of galaxies exerting a brutal gravitational dominance over our local region. We thought the Great Attractor was the sole engine of our movement, but the math did not perfectly align. The mass of the Great Attractor was not quite enough to explain the sheer velocity of our galaxy. There was a missing component in the gravitational equation. The breakthrough came when scientists stopped looking exclusively at what was pulling us and started looking at what was pushing us. In physics, a severe lack of matter operates exactly like a repulsive force. If you are suspended between a massive mountain of lead on your right and an empty vacuum on your left, you will move toward the lead, but mathematically, you can model it as if the vacuum is actively pushing you away. By analyzing the cosmic microwave background, the ancient radiation from the Big Bang, astronomers discovered a cold spot in the opposite direction of our movement, a region of such profound emptiness that it acts as a massive gravitational repellent. It is known as the dipole repeller. We are not just being pulled by the dense walls of the void, we are being violently expelled by the dead space behind us. The Milky Way is caught in a cosmic riptide, pushed by the emptiness and dragged by the distant mass, fleeing the center of the KBC void at terrifying speeds. We are part of a local structure known as the Laniakea supercluster. It is a massive network of 100,000 galaxies, stretching 520 million light-years across. In maps, it looks like a glowing, beautiful feather floating in the dark. It is our cosmic continent. But when you zoom out, the beauty of Laniakea takes on a darker tone. The entire Laniakea supercluster, with all its 100,000 galaxies, is completely swallowed by the KBC Void. We are just a sparse, fragile string of matter suspended in the middle of a 2 billion light-year dead zone. Even our grandest local structures are insignificant when compared to the vastness of the empty sphere that contains us. We map the cosmos relying on the light that reaches us. But the deeper we look into the mechanics of this void, the more we realize that our geography is actively hostile to observation. The void is not just a location, it is a physical barrier that corrupts the very data we use to understand reality. When light travels through the universe, it is not simply coasting through an empty, passive vacuum. Space is an active medium, heavily warped and distorted by the mass it contains. Every time a photon passes near a dense supercluster of galaxies, it falls into a gravitational well. It gains a tiny amount of energy as it dives into this well, and it loses that exact same amount of energy as it climbs back out. In a perfectly uniform universe, this energy exchange balances out perfectly. The light arrives at our telescopes pristine, its story intact, but the massive structural anomaly we inhabit shatters this balance, creating a physical barrier to the truth. Because we live deep inside a gravitational crater, the light arriving from the distant universe must climb an immense, invisible hill to reach us. It enters the outer boundaries of the KBC Void, transitioning from a region of high cosmic density into our sprawling dead zone. As the light travels across these 2 billion light-years of emptiness, the universe continues to expand, physically stretching the gravitational wells themselves. By the time the photon climbs out of the well and hits our sensors, the geometry of space has changed. The light loses energy in a way that our standard physics models struggle to map. It is as if we are trying to observe a pristine landscape through a severely warped curved pane of glass. Every measurement we take, every calculation we make regarding the age and speed of the universe is fundamentally corrupted by the distorted glass of our own cosmic geography. This is the exact point where modern physics breaks down. We have slammed into a mathematical paradox that offers no comfortable escape. On one side of the paradox, we have the standard model of cosmology. It is the most successful intellectual framework in human history. It relies on a specific blend of normal matter, cold dark matter, and a constant force of dark energy. This model works flawlessly to explain the fading echoes of the Big Bang. It perfectly maps the distribution of the largest cosmic structures. But this entire model is violently dependent on the cosmological principle. It requires the universe to be a uniform, even distribution of mass. According to the absolute laws of this model, a void 2 billion light-years wide is a statistical impossibility. The mathematics of the early universe simply do not allow for it. The gravity of dark matter should have crushed such a massive anomaly long before it could form. Therefore, if the standard model is correct, the KBC void cannot exist. On the other side of the paradox, we have the cold, unyielding mechanics of local observation, the redshift of nearby galaxies, the mechanical charting of millions of coordinates, the distinct gravitational currents pulling us outward. All of the raw physical data screams that the void is real. It is not a glitch in the software. It is a tangible, measurable region of dead space. And if the void is real, it perfectly explains the nightmare of the Hubble tension. It explains why the galaxies near us appear to be accelerating away faster than the rest of the universe. They are simply falling toward the dense walls of our local crater. We are trapped in a binary trap. If the void is an illusion, then our local measurements of the universe expanding at 73 kilometers per second per megaparsec are real, which means our fundamental understanding of dark energy and the Big Bang is entirely wrong. We would have to invent new exotic physics, forces that somehow operated in the early universe and vanished, to explain the discrepancy. But if the void is real, then our local measurements of expansion are heavily artificially inflated by the gravitational pull of the void walls. This would solve the expansion mystery, but it would completely destroy the cosmological principle. It would mean the universe is not uniform. It would mean the foundational assumption we use to build modern physics is a lie. Astrophysicists are currently locked in a desperate battle to reconcile these two realities, but the math refuses to yield. You cannot negotiate with gravity. The struggle is playing out in the most advanced observatories on Earth. We are pushing the limits of engineering to see just how deep this anomaly goes. We use instruments like the James Webb Space Telescope, placing it 1,000,000 miles away from the thermal interference of Earth, shielding it with layers of Kapton foil to keep its sensors at a fraction of a degree above absolute zero. We capture infrared light from the very first galaxies that ever ignited in the deep dark. We map Cepheid variable stars in galaxies millions of light years away, and we measure the violent explosions of white dwarfs with an accuracy that borders on the impossible. The researchers compile massive datasets, utilizing thousands of exploding stars, trying to find a smooth, gradual transition where our local void blends into the normal density of the universe. They assume that if they look just a little further, the anomaly will end. The numbers will average out. The cosmological principle will be saved. But the data remains fiercely uncooperative. The edge of the void is not a smooth gradient. It is a sharp, jagged drop in density. The barrier is real. The mathematics reveal a merciless truth. The less matter there is to anchor the space, the more violently that space tears itself apart. Without the gravitational glue of deep superclusters to hold our local region together, dark energy dominates our environment with a terrifying efficiency. We are experiencing the accelerating death of the universe at a localized, artificially high rate. We are not simply researchers observing a phenomenon from a safe distance. We are the subjects locked inside the experiment. We cannot step outside the KBC Void to verify its existence from a neutral vantage point. We cannot send a probe 2 billion light-years away to look back and take a picture of our isolation. The speed of light is the ultimate cage. By the time a signal sent from Earth reached the edge of our void, the Sun would be a cold, dead cinder, and the Milky Way would have collided with Andromeda, forming a dead elliptical graveyard of stars. Everything we know about reality has to be deduced from the inside of a sinking ship. We are measuring the water rushing in, calculating the angle of the deck, and trying to reconstruct the entire ocean based only on the violent currents ripping through our cabin. This creates an epistemological nightmare. How much of our physics is universal, and how much of it is merely a local weather report? If our geometry is skewed by the missing mass of 1 billion galaxies, what else are we misinterpreting? The fundamental constants of nature might not be entirely constant. Our measurements of dark matter could be heavily distorted by the fact that we live in a region where dark matter has been largely excavated. The barrier is not just physical. It is a barrier to human knowledge. We have spent the last 400 years since the invention of the telescope, assuming that the cosmos was a vast, open book waiting to be read. We believed that with enough time, enough mirrors, and enough processing power, we could map it all. We assumed the universe wanted to be understood. But the void suggests a much colder reality. The universe is not a textbook. It is a blind, mechanical engine, indifferent to our desperate need for order. It constructs massive, impossible anomalies and leaves us trapped inside them, looking out at a distorted reality through a veil of missing gravity. We are forced to question the very bedrock of scientific inquiry. If the local data contradicts the cosmic data, and both data sets are mathematically flawless, then human logic itself has hit a wall. The tension in the numbers is not just a puzzle for academics. It is the sound of our physics fracturing under the weight of an impossibly large darkness, pointing toward a future where our isolation will only become more absolute. The consequences of residing inside a 2 billion light-year dead zone extend far beyond a mathematical disagreement among astronomers. The void is not merely a static location in space. It is an active, relentless mechanism of erasure. To understand our future, you must understand the true nature of the force tearing the universe apart, and how our specific geography gives that force a terrifying advantage. We call it dark energy. It is a placeholder name for a phenomenon we can measure but cannot comprehend. It is an inherent property of space itself. As space expands, matter dilutes. The galaxies spread out, the gas clouds thin, and the overall gravitational strength of the universe weakens. But dark energy does not dilute. It maintains a constant, unyielding density. For every cubic meter of new space that is created in the expansion, a new identical amount of dark energy is born with it, exerting a repulsive pressure that pushes space apart even faster. In the grand architecture of the cosmos, gravity and dark energy are locked in a brutal war of attrition. In the dense filaments of the cosmic web, where massive superclusters reside, gravity is currently holding the line. The overwhelming concentration of matter creates local pockets of resistance, where the expansion of space is temporarily stalled. But we do not live in a dense filament. We live in an evacuated crater. Because the KBC Void is missing 20% of its mass, gravity has been severely crippled in our local neighborhood. We are missing the structural anchors required to resist the underlying expansion of the vacuum. Therefore, inside our 2 billion light-year perimeter, dark energy has achieved absolute uncontested dominance billions of years earlier than it will in the rest of the cosmos. The void is accelerating its own emptiness. This localized acceleration dictates a deeply unsettling future for our corner of reality. We are currently caught in a cosmic riptide, drifting outward toward the denser walls of the void. But the expansion of space driven by dark energy is exponential. There will come a precise mathematical moment when the space between our local group of galaxies and the distant walls of the void will begin expanding faster than the speed of light. This does not violate the laws of physics. Nothing can move through space faster than light, but space itself can expand at any speed it dictates. When this threshold is crossed, we will hit the cosmological event horizon. It is a physical, insurmountable barrier of information. Imagine you are standing on the deck of a ship in the middle of a pitch-black ocean. In the distance, you can see the faint lanterns of a massive fleet surrounding you. But the water between you and the fleet is physically multiplying. The distance is growing so violently that even if the other ships shine their brightest searchlights directly at you, the beams of light cannot cross the multiplying water fast enough to reach your eyes. The light from those distant galaxies will simply stop arriving. The expansion of the void will stretch their photons so severely that the wavelengths will flatten out entirely. The light will shift from the visible spectrum down into the infrared, then into microwaves, then radio waves, until the wavelength is wider than the universe itself, fading into the absolute zero static of the vacuum. The walls of our void will visually and physically dissolve. The thousands of galaxies we currently map with our digital sky surveys, the massive glowing filaments of the cosmic web, the superclusters pulling at our edges, all of it will vanish. Not because they cease to exist, but because the physical universe has severed our optical connection to them. The void will isolate us completely. The sheer physical mechanics of this erasure will fundamentally alter what it means to be a conscious observer in this universe. Right now, astrophysics is possible because we live in a privileged epoch of cosmic time. We exist in a narrow, temporary window where the universe is old enough to have evolved complex biological observers, but young enough that the evidence of its creation has not yet been scrubbed away by the expansion of space. When we point our radio telescopes into the empty black, we capture the cosmic microwave background. We hear the echoes of the Big Bang, the primordial heat left over from the very first moments of time. This radiation gives us the absolute baseline for all of our physics. It is the undeniable proof that the universe had a beginning, that it was once a dense, superheated singularity. But inside a rapidly accelerating void, this ancient radiation is also being destroyed. As the space within the KBC Void continues to multiply, the ancient microwaves of the Big Bang will be stretched out of existence. The temperature of the background radiation will drop so close to absolute zero that no instrument, no matter how perfectly engineered, will be able to distinguish it from the quantum noise of empty space. The thermal fingerprint of creation will be permanently erased. We must project our minds forward to understand the sheer existential weight of this loss. Trillions of years from now, long after our sun has died and the Earth has been incinerated, the local group of galaxies will undergo a massive, violent transformation. The Milky Way, Andromeda, and dozens of smaller dwarf galaxies are gravitationally bound to each other. Despite the expansion of the void, our immediate local gravity is strong enough to keep us together. Eventually, these galaxies will collide. The supermassive black holes at their centers will spiral into each other, sending gravitational waves rippling through the dark, before merging into a single, colossal, elliptical galaxy. A solitary, glowing island of aging red dwarf stars and cold gas. Imagine a future civilization evolving on a planet orbiting one of those long-lived red dwarf stars in this merged supergalaxy. They will look up at their night sky and see a brilliant canopy of local stars. They will build telescopes. They will construct massive observatories and develop the scientific method. They will look past the edges of their galaxy, expecting to find answers. And they will find absolutely nothing. Because the void has erased the cosmic microwave background, they will find no evidence of a Big Bang. Because the void has pushed every other galaxy beyond the cosmological horizon, they will see no distant structures, no redshift, no expanding universe. They will stare out into an infinite, perfectly black, featureless abyss. Their most brilliant physicists will compile the data. Their mathematics will be flawless. Their instruments will be perfect. And their absolute, scientifically verified conclusion will be that their single galaxy is the entire universe. They will deduce that they are floating in an eternal, static, infinite emptiness. They will believe that nothing exists outside their local cluster of stars, and that nothing ever has. And they will be completely mathematically justified in their conclusion. The physical evidence required to prove otherwise will have been systematically deleted by the void we currently reside in. This is the most terrifying consequence of the KBC Void. It demonstrates that the universe is actively hostile to the preservation of truth. Physics is not a permanent record, it is a decaying manuscript. The fundamental laws of the cosmos are slowly dismantling the evidence of their own existence. We are only able to measure the universe right now because the void has not yet finished its work. Every redshift we calculate, every distant supernova we observe, every map we construct of the cosmic web is a fleeting snapshot of a reality that is violently deleting itself. We are archiving the architecture of a collapsing building while standing inside it. The void proves that our physical location heavily dictates what we are allowed to know. The geography of the cosmos is a filter that distorts, bends, and eventually blinds the observer. The anomaly we have discovered in our measurements is not just a frustrating puzzle for cosmologists. It is a preview of the sensory deprivation that awaits all matter trapped in this sector of space. As the edges of reality accelerate away from us, leaving us stranded in the dead center of an expanding, cold vacuum, the sheer scale of our isolation forces a devastating perspective. We are a temporary phenomenon, measuring a temporary universe, entirely unaware of how much information has already been hidden from us in the dark before we even opened our eyes. For thousands of years, the act of looking up at the night sky was an act of profound connection. We believed we were looking out into a crowded, continuous tapestry. We assumed that the mechanics of reality were a shared architecture. From the earliest stargazers mapping the constellations to the orbital observatories capturing the deep field, the underlying philosophy of astronomy has always been one of belonging. We thought we were active participants in the grand cosmic web, occupying a normal representative patch of space. But the KBC Void strips away this comforting illusion with a mechanical, unapologetic precision. It forces a radical, almost violent re-evaluation of what it means to exist on this planet. We are not citizens of the cosmos. We are castaways. We are drifting in a hollowed-out sector of space, completely detached from the primary engine of the universe. Consider the sheer mass that is missing from our surroundings. The billions of galaxies, the massive clusters of dark matter, the sprawling filaments of primordial gas that should be here, but are not. They were pulled away to the dense edges of the void long before our sun even ignited. We are the leftovers. We are composed of the sparse, stagnant dust that was trapped in the center of the vacuum, lacking the gravitational momentum to escape. Human history, the evolution of life on Earth, every civilization we have ever built, is merely a localized chemical reaction occurring deep within an abandoned, desolate region of reality. We like to view human consciousness as the universe waking up to finally understand itself. But if the universe is waking up here, it is doing so in a barren, forgotten room, light years away from the actual structure of the cosmos. The night sky that we see is the ultimate geographic deception. When you look up and see thousands of stars, when you see the glowing, cloudy band of the Milky Way stretching across the horizon, it feels infinite. It feels heavily populated. But every single star you can see with the naked eye, every constellation you can name, is fiercely local. You are not seeing the universe. You're only seeing the interior of our tiny, immediate lifeboat. It is the equivalent of standing in the center of an empty, lightless continent and assuming the world is bright because you are staring directly into a single match struck in your own hand. The overwhelming majority of reality is out there, beyond the 2 billion light-year dead zone, and it is accelerating away from us. The universe does not operate with malice, nor does it operate with purpose. It is a blind thermodynamic engine governed by equations that do not account for our existence. The expansion of the void is not a tragedy. It is simply a physical process, but it is a process that guarantees our ultimate isolation. The void is not just a geographic anomaly. It is the physical embodiment of our insignificance. It is a mathematically proven barrier that dictates the limits of human knowledge. We have spent centuries building physics models, refining our mathematics and assuming that our local observations could be universally applied. We assumed that because the math worked here, it worked everywhere. But the KBC Void reveals the arrogance of that assumption. Our physics are heavily distorted by the absence of gravity. Our measurements of time and expansion are artificially inflated by our own emptiness. We are trying to deduce the shape of an entire ocean based solely on the violent, localized currents of a sinking ship. In the quiet vacuum of deep space, our satellites will continue to function for a time. The beryllium mirrors will continue to capture whatever sparse photons manage to cross the multiplying distance. The supercomputers on Earth will continue to crunch the data, plotting the coordinates of a shrinking, observable universe. But the machines cannot feel the existential weight of the numbers they output. They only measure the growing silence. As dark energy continues to dominate our local environment, this void will only grow larger. The space between us and the heavy walls of the cosmic web will continue to multiply. The structural integrity of our surrounding space will fail. The galaxies on the edge of our vision will redshift into oblivion, pushed past the cosmological horizon, severing their optical connection to us forever. The universe is actively dismantling the evidence of its own architecture, and we are trapped inside the deletion zone. There is no grand revelation waiting for us at the edges of our instruments. There is no hidden meaning to be uncovered in the darkness. There is only the cold, unyielding reality of the vacuum. We are trapped in a gravitational crater, watching the rest of reality accelerate out of reach, taking the truth with it. The lights are systematically fading, the data is fracturing, and as the void expands, it ensures that eventually the universe will not even leave a record that we were ever here to look up.